Hi, Assalamualaikum. My name is Amirul Aiman. I will present about problem-based learning engineering Math 2. The group member are the leader Chi Ziyi and Eng Shiyuan and me, the lastly Kamarul Rizwan bin Sulaiman. Ordinary differentiation equation are pure and applied mathematics, physics and engineering in the calculation. Application of ordinary differentiation equation divide to two parts. One, population growth and Newton's law of cooling. Population of growth, we learn about increased number of population human or bacteria or anything else related with increased number or decreased number. And Newton's law of cooling are about temperature, rate of change temperature, like as the body and melting of ice. And that's all from me. Thank you.
Good morning, everyone. My name is Eng Xuyan, and today I would like to share about the PBL table. Part 8, question 10. The facts of this question is: firstly, the chemical reaction forms when a chemical X converts into chemical Y. Next, the rate of conversion of chemical X is proportional to the amount. Next, the end of 1 hour, 50 grams of chemical X remains, and while at the end of 3 hours, only 25 grams remains. 4. Find how many grams of chemical X were present initially. Find how many grams of chemical X will remain after 5 hours. And also find how long will it take for the chemical X to become 2 grams. Next, the idea of this question. Firstly, how to use the exponential decay model formula to solve the problem. The formula is given here, where Q is the amount of a chemical X present at any time. T. Q is the initial mass and K is the constant. Next, find the value of grams of chemical X present initially by using the formula. Next, find the grams of the chemical X that will remain after 5 hours, and also find the time taken for the chemical X to become 2 grams. The learning issue of this question is how to find the exponential decay model formula by using the formula given, and also how to find the value of the chemical X at the initial, and also how to find the value of chemical X remain after 5 hours, and also how to find the time taken for the chemical Y to become 2 grams. The action plan and result need is by group discussions, education library, and also the website. Next, the PBL table for part B, question 7. The facts in this question is the room temperature when cooled a pot or soap is 20 degrees Celsius. Next, the temperature when the soap of the stove is 118 degrees Celsius. Next, the soap will be cooked to 100 degrees Celsius after 20 minutes. 4. Find how long will it take to cool to this temperature. Suppose can eat the soap when it is 18 degrees Celsius. 5. Find what will be the temperature of the soap after 45 minutes. Next, the idea of these questions. First, how to use the Newton law of cooling for calculate. Next, the formula of calculation is shown here. Where K is the proportional constant, T is the object and the temperature of environment, T is the surrounding of the object. Temperature surrounding the object. Number 3, find the time taken to cool the soap at 18 degrees Celsius. And 4, find the temperature of soap after 45 minutes. The learning issue of this question is, firstly, how to find the Newton laws of cooling by using the formula given. Second, how to find the time taken to cool the soap at 80 degrees Celsius, and also how to find the temperature of soap after 45 minutes. The actual plans or result need is by group discussion, resource by UTation library, and also by the website. That's all for me. Thank you.
Hi everyone, my name is Chuzi. Now I'm going to explain about problem and solution. For part A, our question given is, a chemical reaction converts a chemical X into chemical Y, and the rate at which chemical X is converted is proportional to the amount of chemical X present at any time. If Q is the amount of chemical X present at any time t, show that the given formula, where Q is the initial mass and K is a constant. At the end of 1 hour, 50 grams of chemical X remains, while at the end of 3 hours, only 25 grams remains. A. How many grams of chemical X were present initially? So now I'm going to find out how many grams of chemical X present initially. For the formula, we got the first equation. Then we plug in T equal to 1, Q equal to 50, and we got the second equation. Next, we plug in T equal to 3 and Q equal to 25, and we got the third equation. In order to get the value of K, we will divide the second equation by the first equation, and we will get e to the power of 2k equal to 2, or k equal to 1 over 2 ln 2. So next we will putting the value of k into the equation 2, and we will get 50. In order to get the value of QO, we will get 70.5. So the answer for A is 70.5 grams of chemical X. Means that 70.5 grams will present initially. For B, how many grams of chemical X will remain at the end of 5 hours? So we put T equal to 5, K equal to ln times square root of 2, and QO equal to 70.5. We sub this all information into this formula, and we will get Q equal to 12.5. Therefore, 12.5 grams of chemical X will remain after 5 hours. This is the answer for B. For C, how long will it take in hours for chemical X to be 2 grams? So let Q equal to 2 grams at T. From the equation 1, which is this formula, we have 2 to the power of minus T divided by 2 equal to 2 divided by 70.5 and equal to 0.0284. So taking log of both sides, we get minus 5.1379. So we will get T equal to 10.2 10.28 approximately. Therefore, quantity of X will become 2 grams after 10.28 hours. For part B, our question given is, suppose you cool a pot of soup in a 20 degrees Celsius room. Right when you take the soup off the stove, you measure its temperature to be 180 degrees Celsius. After 20 minutes, the soup has cooled to 100 degrees Celsius. Suppose you can eat the soup when it is 80 degrees Celsius. How long will it take to cool this temperature? What will the temperature of the soup after 45 minutes? So first, we can use Newton's law of cooling, which is this formula, to find out how long will it take to cool to 80 temperature. T is our temperature, K is constant, TA is temperature of surrounding environment, Ti is initial temperature of object. Here given this all information, and we sub in this all value, and we got the constant equals to 0.03465. Okay, this is a value of K, which is constant. Now we want time at temperature in 80 degrees Celsius. So we sub in this all and subs the value of K into the formula, into this formula. Now taking log of both sides, ln 0.375 equal to minus 0.03465t, and t is equal to 28.3 minutes. Therefore, the soup will cool from 100 degrees Celsius to 80 degrees Celsius in 28.3 minutes. So we're going to find out the temperature of soup after 45 minutes. So from using the same formula, sub in the information, and we taking the, oh sorry, I'm sorry. So means the information, and we got T equal to 53.47 degrees Celsius. Therefore, the temperature of soup is 53.47 degrees Celsius after 45 minutes. Okay, that's all for me for my explanation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Kamarul Rizwan bin Sulaiman, and I will continue this presentation in discussion and calculation. So, first order ordinary equation, or ODE, is very important in our daily life because it aids in solving basic daily problems. ODE used to calculate the change of state of a model over time. For example, for part A question 10, ODE was used to determine the growth and population, where we need to calculate decreased amount of chemical substances over certain time. This proves that ODE was not only used to solving daily problems, but also used in scientific fields. For part B, question 7, ODE will apply a Newton's law of cooling, where we were asked to calculate the time taken for the soup to reach certain temperature. This kind of problem may also happen in our daily life, and ODE helps in solving the problems. That's all from me. Thank you.